therapy space or the oncology space, and what you view as the core competencies of the company. Thank you.
Yeah, absolutely. Before I answer that question, so Ralph Brandenberger is the man we have key man insurance on. He's our VP of Technical Ops. He runs all of our manufacturing and process development, analytical development, CMC, the whole 9 yards when it comes to what's very important to us, which is the manufacturing function. And also you have Nadir Mahmood, who is our Chief Financial and Business Officer. He's also with us today. And Nadir and I are going to answer this first question. So let me just start with, when you asked about how we position ourselves in oncology, Peter, what I think is really cool about NK cells is, and first of all, we love the whole cell therapy space. T cells, NK cells are two cell types that we think are great cell types. There's obviously proof of concept with CAR Ts. But unlike CAR Ts, the nice thing about NK cells is, while there's a benefit to the long-lived effects of CAR T cells, of the adaptive immune system sort of kicking in and that expansion going on for a long period of time, NK cells act like other chemotherapeutic agents and antibodies. There's a shorter life in the patient. They tend to go in, they tend to do the job they need to do, which is rapidly attack the tumor. They tend to focus only on tumorigenic cells or virally induced cells, and then they tend to get out of there. So, you're looking at, dosing them. You can dose them every week, every couple of weeks, along with standard chemotherapy, immuno-oncology agents, and interestingly, probably other cell types, right? So NK and T together look really interesting when you combine the power of that rapid onset of the NK cell with rapid tumor reduction, along with a longer-term adaptive immunity of the T cell. We actually have an NK plus T program, which I know we'll talk about a little bit later. But so oncology, you can take any number of oncology targets and put them on the backbone of the CAR NK, and then you've got, sort of a platform that can produce multiple targeted therapeutics. Usually, the way we classify it is we can do an IND a year once we get, the company up and running. And now that we're 100 plus employees, we're working very diligently towards that. So oncology, we feel we're really well positioned. Cell therapy space, we're talking about the innate immune system versus the adaptive immune system. You're familiar with FATE, you know what they do. They do NK cells as well. And so, we're just really happy to be in the space. And we, by the way, the other thing that we've done in the space to position ourselves, our founder, Dario Campagno, was involved in the T cell space. He was a pioneer in the T cell space. He moved on to NK cells when he was at St. Jude, and now he's at the National University of Singapore. Much of our technology comes from him, and he's got a broad knowledge base in the cell therapy space in general. So we're real excited to be working in this field and working along with all the other cell therapy players. And we feel we're in a great position because what we've done is sort of jump-started where we are in clinical development. We haven't had to do the incremental additions to our programs that others have had to do because they've done them. And we have come in at a really good time where we understand the space and understand what folks have done and can engineer ourselves, can gene edit, can do all the things others can do. We're just starting in a much better place. And so, our first program, NKG2D, which is a natural receptor on an NK cell, is a target that's got 8 ligands that are associated with solid tumors and hemalignancies, kind of a perfect entree for an NK cell. And particularly since they're allogeneic and off the shelf and cryopreserved, you've got a position here where you can hopefully see some monotherapy results and then hopefully also be really well combinable with other chemotherapeutic agents. And I know I just gave probably the whole answer to Nadir, but if you have anything additional that I...
No, there's plenty to kind of question around and explore further. Just on the NK cell approach, I mean, what's kind of de-risked it in your mind? I mean, and also what has been the kind of important data out there that's just said, okay, we kind of need to set up a company around NK cells, and we're seeing a number of these private companies starting to emerge from stealth mode.
Well, just to be clear, we started long before there was clinical data out there. We started the company in 2015. It's before some of this sort of landmark data that came out of Katie Rezvani's lab was introduced to the oncology and hematology community. So we started based on our founders' technology and the knowledge that James, Ralph, and others that started with us early on had in the cell therapy space. So we were basing it on an innovative new cell therapy approach. Now, since data has come out, and since even as early this year at ASH, there have been just a plethora of companies that have started. So there's excitement in the space. Having said that, by the way, if you look at the number of NK cell companies, it doesn't even come close to the number of T cell companies, and there's clearly been a lot of T cell companies with a lot of success. But Nadir, why don't you grab that one and maybe talk a little bit about Katie's data and how people maybe look at that in terms of validation?
Yeah, I mean, I think there's been some great points of validation, but like Paul said, for us, it really sort of started with trying to accomplish and get over some of the key limitations that had been otherwise sort of slowing down NK cell activity and demonstrating that there was, some real power behind these naturally killing cells that are also naturally allogeneic, right? And I think that was sort of the key foundational piece. And then being able to enhance their persistence, being able to target them by engineering are sort of the key elements. And now as we look at data coming out of MD Anderson, with their CD19 CAR-NK program and what they published in New England Journal of Medicine, really demonstrating some tremendous responses, complete responses in 7 out of 11 patients with B-cell malignancies, with no reported CRS or neurotoxicity. It's sort of this combined power of a cell type that can be engineered, that can be dosed not once but multiple times, that is already allogeneic. So then can you make it off the shelf? And then really with a safety profile that is unique and different from what we're seeing with CAR T therapies. I think all of that translates to something that is really compelling, really exciting. And we're sort of really pushing forward with our first couple of programs to also demonstrate how our platform can really recognize that value.
And Peter, by the way, the key man in the bottom left-hand corner of my screen anyway, has been able to cryopreserve these cells and put them in vials. And I think that's a major advantage and opportunity for NK cells. If you can actually freeze and thaw these cells that have these lytic granules that like to explode when you freeze and thaw them, and then put them in a vial so you can ship them like a normal, off-the-shelf therapeutic. This is a huge advantage. Our goal is to take the paradigm shift out of the institutional setting into an outpatient setting, infusion center setting, community-based setting. So we want to make it as easy as possible, both in the shipping as well as the freezing and thawing, as well as then administering to the patient without the need to work with what could be a cumbersome dose form.
What would have been I guess I've kind of looked at it as T cells, which is potentially easier to work with, and NK cells have taken some time to kind of catch up essentially with that technology to understand them. Is that the way you kind of think about it, and perhaps you get more functionality out of the NK cell than you could out of a T cell?
Yeah, it's interesting. That's a question that we addressed when we first started the company back in, when we really started talking to investors in 2017 and 18. It's just that the T cell, folks really knew T cells, understood T cells, understood that adaptive immune system. And I think, the NK field kind of came along behind it, and all of a sudden people went, wait a minute, why don't we try this, right? I think that's really how it started, but James would have a much better perspective on that than I would.
I think what Paul said is correct. There's just been many more years of research done on T cells that has enabled a lot of the progress in the field. But, in point of fact, NK cells have greater inherent cytotoxicity on a per cell basis. Once we master the ability to engineer them, we can redirect them and really, both enhance that potency and direct it towards specific targets. And I think in our experience anyway, it's easier to expand NK cells to large numbers without exhausting the cell, so they'll retain their activity even when we expand them to make several hundred doses. That's historically been very difficult to do with T cells, which tend to become anergic after a number of rounds of proliferation. So there is a lot more background in the T cell field, but I don't think that reflects an inherent advantage of T cells over NKs.
Is there a kind of a clearer route, or are there more advantage or drawbacks with adult donor cells versus fetal, cord blood, placental? How should we think about what the best system is? Is there a best system?
You're asking me my favorite questions today, Peter. Thank you. So we think that once we're all generating clinical data, no one's really going to care what starting material we all start with. We happen to, so Ralph and James both spent years at Geron. James then spent years at Dendreon. Ralph's been involved in the cell therapy space for a long time, and they've worked with iPSCs as well as other, cell types or starting materials. So look, we like the healthy donor starting material. Let me tell you why. And again, this is not to take away from an iPSC. We love those too. And one day we might actually think about, experimenting with iPSCs. But what we like about the healthy human donor derived cell is it starts naturally as an NK cell. You don't need to alter it to turn it into an NK cell. It's already an NK cell. And when you isolate those NK cells in the leukopak, you're talking about, volumes of NK cells. And so then when you can rapidly and robustly expand them with our founder Dario's K562 cell line, then what you end up with at the end of that process, you can also engineer them with, with targeting, proprietary targeting. So the K562 cell line is proprietary. We add a membrane-bound IL-15, which is also proprietary. Then we do proprietary targeting, like our CD19 or our NKG2D. And then we do the cryopreservation, the freeze and thaw, and the filling in vials. When you put all that together, you've got quite a, optimum cell and starts naturally from a healthy human donor. You can also gene edit them. You may not be able to gene edit them 5 or 6 or 7 times. And our point of view on that is if you need to gene edit an NK cell 5 or 6 or 7 times, are NK cells really, appropriate, or are you not starting with an NK cell? It's just hard to to imagine needing to edit something that much. So we can edit cells. We can also select in our donors for things like CD16. Rather than engineer it in, we can select with our donors. So that's why we like healthy human donor-derived cells. And we don't think that, we like the platform. There's cord blood cells. There's iPSCs. You can start with a starting material and expand, any kind of cell type you want to expand. Each one of them is going to have its own expansion and its own manufacturing, and none of those platforms are going to do it easier than another one.
Good. Thank you. I think
Ralph, did I get that 100% correct?
Yes.
Thank you. Sorry, I keep stealing everybody's answers, Peter. I'm sorry. I get too excited.
No, it's a fantastic field. Great set of answers. Maybe I should move on to clinical products. And so you've got NKX101 phase 1 for high-risk MDS and AML. Just if you kind of talk through the strategy there, why you're targeting AML, what subsets of patients, and I guess when we start to see the first data there.
Right. So, Kanya, why don't you walk Peter through why AML and the systematic literature review. And Peter, what we've done is we have guided towards having a handful of patients worth of data by the end of this year. We don't know where we'll present it, but we're guiding towards the end of the year. We're dose escalating now in that trial. And so, we're hoping to have at least a couple of cohorts of patients. So if we see a dose response, we can talk about that as well. But Kanya, why don't we talk a little bit about the AML and where else NKG2D is going?
Sure, happy to. So we have chosen relapsed refractory AML and high-risk MDS patients for our first in-human trial for a couple of different reasons. The main reason being the extensive information in literature with non-engineered NK cells. So non-engineered NK cells since about 2005 have been evaluated in a variety of different patients, largely single-center academic trials. And a big subset of that patient population is AML. There's a huge history of scientific knowledge which ties AML and NK cells. In fact, NK cells were first discovered in the context of AML. So when in the non-engineered NK experience, when patients with relapsed refractory AML were given these cells after lymphodepleting chemotherapy, responses between 20 to 50% were noted in different small single-center trials, average of about 30-35%. So that made it the natural indication to start with. Having said, and the reason for that, of course, is NKX101 expresses as a CAR NKG2D. And NKG2D is the main activating receptor on a regular non-engineered NK cell. So that's where we feel the strongest rationale for AML comes in, or indeed for putting NKG2D on an NK cell or targeting using that to target patients with cancer. Beyond AML and MDS, of course, these NKG2D receptor on NK cells, it recognizes about 8 known stress ligands, which are found on cancerous cells, including AML. So we are open to the possibility that as data comes in of really broadening our clinical development plan, because this is not targeting a single lineage-specific marker like CD19. So there is the opportunity to potentially be as broad a development plan as one of the checkpoint inhibitors.
Thank you.
To be clear, we also have a CD19 program, Peter, whose IND will be filed by the end of this quarter. So we're on track for that too. So we have a nice balanced pipeline with this broad development program that Kanya just outlined with NKG2D, but also with sort of a well-known proof of concept target, which when you do all the things I talked about before with an NK cell, all the bits of proprietary technology that we have, you've got a really very competitive CD19 targeted CAR NK cell amongst all other cell types as well. So and potentially combinable with those also.
For 101, when we see the data, sounds like ASH kind of year end, what do we want to see in that data? I mean, is it response rates, or will it be in its early infancy where we're kind of looking at infiltration of cells, etc.? So just if you kind of help frame what we should be looking for.
Yeah, let me just say we don't have a crystal ball, and this is our first in human study, and this is AML. This is a very difficult to treat disease. These are refractory and relapsed patients. So of course we'd hope to see a dose response, right, in a couple different dosing cohorts. But Kanya, maybe you want to add to what you think would be the appropriate kind of what you would see in the early stages like this.
Yeah, so in our phase 1 trial, we have a whole slew of correlative analyses that we have planned. So certainly any such data that's available at that time would also be something that we would look to put in as part of understanding how NKX101 works in the clinic. So response rates, correlative analyses, some durability, of course. One of the things to remember is definitive treatment for AML continues to be transplant. So we will keep that in mind. We are planning a follow-up to collect information. We also require patients get disease assessment before they get further treatment and so on, so that we get a handle on the durability as best as we can in our patient population. So it's a combination of some of those things. And of course, first in human or safety, which is the primary objective of the trial.
And this is a local delivery initially. And is that to just enhance the chance of success, or what's the rationale?
So maybe I'll clarify that the AML study is systemic. We do give, leukemia is in the marrow and peripherally, so it is a systemic trial. We do plan a local regional trial for our solid tumors, for liver localized tumors, but that's coming up in 2022. Yeah.
Gotcha. And so
that particular trial, Peter, is as we look at solid tumors, with our first target is to get as many cells into the target organ as possible. And since HCC is there and colorectal cancer isolated to the liver or cholangiocarcinoma, then we're using a well-known procedure to get as many cells in to get as quick a proof of concept. And we would then bridge, by the way, to systemic delivery, but we want to see quick proof of concept first. That's why we're doing that.
Gotcha. Okay. And then there's, you're kind of starting the trial in AML, and there's kind of a haplo component of it before a kind of more of an off-the-shelf, kind of unrelated, mismatched component. Is that kind of a similar thing to kind of enhance the chance of success? Just if you could walk me through that.
Yeah, so let me start. The design is such that when we first went into this space, we looked at the systematic literature review and all the investigators like Dario who had dosed patients with these unengineered NK cells. And those were all haplomatched. So we thought we'd start haplomatch, we'd dose escalate, we'd see if haplomatching makes a difference, and we bridge into mismatched cells once we've established a dose that we think is the appropriate dose. So it's really a process to be thorough and to follow up on what's in the literature already. But the NKG2D as well as CD19 and all of the targeted CAR-NKs will all be off the shelf and mismatched. But we're going to start here and dose escalate first.
Would we get the haplotype matched and the unrelated mismatched kind of in two different data sets, or could we get those initial first 12 patients sooner?
Kanya?
Yeah, so the current plan, as Paul said, is to have a handful of patients worth of data, first 6 or so patients in the first few dose levels. And as you remarked, Peter, that we do start with haplomatched and then we go into unrelated. At the same time, of course, we are constantly going to be looking at how the trial is, what's happening on the trial to see if there's an opportunity to try and, amend the design and so on, to look at other ways of trying to get the trial.
Maybe in the last minute, just kind of touch again on the solid tumor approach. I know we've seen a lot of kind of AML, NK cell data, but what kind of de-risks that solid tumor opportunity and approach?
So it's basically the dose escalation and the data we get in AML and the dose that we get there will inform us, what dose we want to use in other indications, including solid tumors. But the biggest de-risking factor we put into the solid tumor trial, given that everybody knows these are much more difficult to treat tumors, was to come up with a creative approach where, as I said before, we get as many cells into the target organ as possible to see what kind of proof of concept we could get first. So that's really the de-risking of that program, along with the AML data and the kind of the dose response that we might see in the first part, the dose escalation part of the phase 1 AML trial.
Great. So unfortunately, we're at that 25-minute mark. So just wanted to thank everybody for joining us today. Really enjoyed the conversations with Paul, James, Kenya, Nydia, Ralph, and Greg. Thanks so much for the time, and thanks for joining us at Barclays Global Healthcare Conference. And I will hand the line back to the operator.